Hello there! In this video, we're going to create a heat engine that will be used in a pop-pop boot. So, what will be shared in this video? Basically, we will share with you all of the material used in making a heat engine as well as a pop-pop boot. Next, we will also be sharing the step-by-step on how we created the heat engine and the pop-pop boot with some modification that has been made. And we will also show you how the pop-pop boot works on the water. Exciting, isn't it? After that, we will show you the relationship of the heat engine with the fundamental of the first and second law of thermodynamics that we had learned in the class before. Let's move forward with the types of material used for our pop-pop boot. The first material used is an empty tin. It is used to create a boiler because it can provide us with a better diaphragm. The second is a marker pen. It is used to trace out all the cutting parts. The third is a knife and a scissor. They are used in the cutting process. Next is sandpaper, which is used to polish the top of the boiler. Meanwhile, epoxy is used for excessive purposes where we use it to glue some part of the device. A copper tube is used to make the exhaust pipe because copper by nature is a very soft metal, thus it is easier to bend. A juice box is used to make the body of the boot, and a sauce bottle cap is used to make a candle holder. In addition, a lighter is used to light up the candle, while the candle is used to provide heat to the engine. To light up the candle while the candle is used to provide heat to the engine. In this section, we're going to share with you a brief explanation and demonstration of the step-by-step fabrication of our design. First, cut the empty tin using a knife and scissors to take the bottom part and the wall part. Then, by using a marker pen, trace out the bottom part of the wall part. Using scissors, cut out the trace part which must be in a rounded shape. Next, make epoxy A and B to connect both the wall part and the bottom part. Now, the bottom and the wall part become into a boiler. Cut 2 holes at the bottom of the boiler to create an exhaust pipe. To build an exhaust pipe, we use a copper tube. Bend the copper tube approximately 90 degrees upward. Glue both boiler and pipe into one. Put the glued boiler and pipe into the water to make sure it is working. How to know whether it is working or not? Let's just give a moment of silence to listen to the sounds made by the engine. Can you listen to the sound made by the engine? Yes, our engine created a pop-pop sounds which indicates that our engine is working. Next, design a boat using an empty juice box using our own creativity. Glue the boiler and pipe to the boat. Next, make a candle holder out of a sauce bottle cap and then put a small candle inside the candle holder. With some creativity, here is our pop-pop boot. In this part, we will share some of the modifications made and the purpose of the modification. The first modification that we made is the angle of the boiler is increased to create a greater gap between gas and the water, thus creating a smooth gas flow cycle. Next, the angle for the exhaust was adjusted toward the water surface to ease the water flow in and out of the boiler. Besides, the tin on top of the boiler is thin to create a better diaphragm that allows the boiler to breathe. Lastly, metal epoxy is used instead of regular epoxy to withstand high temperatures. Here comes the best part of designing the device, which is the working principle. In this section, we will share with you how the device works and the basic principle of the device. Therefore, let's watch how our pop-pop boat sails on the water. isn't it? But how exactly the pop-pop boot works? A pop-pop boot is powered by a very simple heat engine. This engine consists of a small boiler which is connected to an exhaust tube. When heat is applied to the boiler, water in the boiler evaporates, producing steam. The expanding steam is suddenly pushed out of the boiler, making a pop sound, and pushes some of the water out of the exhaust tube, thus propelling the boat forward. Easy, right? Let's move to the applications of the first and second law of thermodynamics. But before that, let's identify the boundary of our device first. After doing some analysis, we found out that the boundary of our device is the surface of the boiler and the exhaust pipes, since it separates the system from its surroundings. Next, we also identify the heat source of our system, which is the candle. A melted candle in the candle holder with a lit piece of the wick provides heat to the system. Meanwhile, the heat sink of our system is the exhaust pipe, since it transfers heat generated by the boiler into a coolant fluid in motion. The direction of energy transfer in the system started from the candle, which creates chemical energy. The amount of energy and power from the candle is the same throughout the process, since the candles used are the same. After that, the chemical energy is converted to heat energy, which produces combustion or flame. Then, the captured heat from the boiler converts the water to steam, which produces internal energy. Steam expands to force water out of the nozzles, which require mechanical energy. When all the important parameters has been identified, we can easily analyze the fundamental of the first and second law of thermodynamics involved in our device. The first law of thermodynamics involves is the heat energy produced by the candle is both lost to the air and absorbed by the engine and water. Thus, none of the energy is destroyed. Meanwhile, the second law involves is the water in the engine being cool, and therefore, when the heat hits the engine, the heat travels through the metal and into the water, thus warming the water. The last part of this section is constructing the first law equation. By assuming the system is in a steady state and the potential energy is negligible, the first law equation obtained is shown in the video. Till then, thank you for watching.